This quick tutorial is on how to read, use, and interpret a solubility curve. It's designed for the high school student. Okay, here is a standard solubility curve. Actually, it's a bunch of solubility curves all superimposed on the same graph. And we have a couple of things that you want to understand about the curve and the graphs. First off is, what are our axes? Our axes are going to be on the x-axis. Generally, it's going to be temperature. And in this case, we have temperature in degrees C. On the y-axis is going to be grams of solute per grams of solvent. And in this case, our unit's going to be 100 grams of water. Our water is our solvent. And grams of solute is going to be the number of grams of the particular species here on the various solubility curves that we have plotted on one graph. Okay, so now the next thing we have to understand about this is a couple of things about how these work, right? So this particular curve, let's just pick one of these curves real quick. So there's a bunch of these curves. You see these lines, and these are dotted lines. Dotted lines are the same thing. They just signify for this particular graph that they're gases versus solids. But let's just choose one of these things real quick. So let's choose the sodium nitrate one, and we're going to draw a line over top of the other line. Okay. Now, what it says is the way these solubility curves work is the following. Anything on the line is going to be considered saturated. And saturated means that the following. You cannot dissolve any more of the solute in the quantity of solvent at that particular temperature and still have a stable solution. If you try to dissolve more than the value there that is on the line by the intercepts of the temperature and the grams of solute, then you're going to have a supersaturated solution that is unstable. If you have a value of grams of solute per grams of solvent at that particular temperature that is less than the value predicted by the curve, you're going to have an unsaturated solution. So let's just pick 3 points here real quick. Let's pick this point here. We'll pick the blue point right on the line, and then we'll pick the black point here. So what it is saying very simply is the following. Very simply is the following. Since I am below the curve here, my red dot is below the curve, I am going to be in an unsaturated solution. My solution is going to be unsaturated. In this case, the solution is going to be supersaturated, because I have more material in there than I should have and be stable. So this is an unstable system. Unstable. This is stable. And my value here is predicted to be a saturated and stable. So the amount that the amount of solute dissolved in the particular volume of solvent at that particular temperature is going to be the maximum you can have and still have a stable system. Okay, so let's look at how this works, and we can make predictions on whether or not a fluid is saturated, supersaturated, or unsaturated. So I've given you a couple of things here, and let's look at them real quick. So the first one is 60 grams of HCl at 50 degrees C. So I'm going to go to 50 degrees C. I'm going to draw a line up to 60 grams. And I'm going to go this way to make sure, in my dot here. And to me, that looks like it's just above the solubility curve of HCl at 50 degrees C. So I'm going to say that that's going to be supersaturated because it's above the line. 40 grams of SO2 at 30 degrees C. So I'm going to go to 30 degrees C. I'm going to go all the way up to 40 grams. And I'm above the SO2 line here by quite a bit, so that's also going to be supersaturated. 120 grams of Na3 at 40 degrees C. So I'm going to go all the way up. And right there, oops, I'm a little bit too far. And so we'll stop here. And again, that's going to be supersaturated. So far, it's all supersaturated. 10 grams of ammonium chloride at 20 degrees C. So I'm going to go to 20 degrees C and 10 grams. And you can see here that I'm way below this line, so I'm going to be unsaturated. Okay. Okay, I added another problem here just to show you what else you can use. So I'm asking you what the number of grams are to make a saturated solution of KCl at 70 degrees C. So how I do this is I'm going to go to 70 degrees C, and I'm going to read up until I get to my KCl value. And there it is, and it's going to tell me that it's somewhere around 48 grams. All right. So let's look at some other problems on the next page. Okay, so here's our last problem for this to show you what else you can do with it. So let's say at 80 degrees C we have a saturated solution of ammonium chloride. So let's quickly draw where that is on here. So it's going to go all up to ammonium chloride at 80 degrees C. And I'm going to go all the way up here, and it's going to be somewhere around 65 grams. So let's say that's around 65 grams. And then it says how much ammonium chloride precipitates out when the solution is cooled to 30 degrees C. So now I'm going to go down the curve. I'm going to cool down until I get to 30 degrees C. And here's my 30 degrees C point. And it says here that I should only have a maximum amount of 40 grams. So I'm going to make it stable. And therefore my value is going to be 25 grams of NH4Cl precipitates out. So I'm just going to put comes out, so I don't have to write precipitate. Okay, so you can start at a saturated solution here. We're going to cool the saturated solution. Therefore now we're in a saturated solution. If we could draw it this way too, and then what the delta is here, that's where we are. Okay, so one last couple of tidbits before the end of the video. Okay, this is just a recap of how these things work. So remember that the curve on there represents the saturation conditions for a particular fluid at both number of grams that you can dissolve and the temperature, and in some cases the pressure of a particular material. So it's going to change with temperature. And then if you know, remember, if you're above the curve, so here's anything above the curve, here's our curve, the blue line's our curve, is going to be supersaturated. On the curve is going to be saturated, right? And supersaturated is unstable. And saturated is stable. And anything below the curve, so it's going to go this way, is going to be stable too, but it's unsaturated. So unsaturated. So saturated and unsaturated are going to be stable. Supersaturated is going to be unstable. So as long as you're on the line, you're going to be stable, or below the line, you're going to be stable. Above the line, you're going to be unstable. That doesn't necessarily mean that you can't put more solute in a fluid to create a supersaturated fluid, but at some point it's going to precipitate out or become unstable and come back out. Right? You're not going to be able to keep that solubility in there forever. Right? It's just unstable. So hopefully this was helpful to everybody, and if not, you can come see me.